room is very small.
Yeah, we need to change that on the...
Let's start. Okay, welcome to gRPC 101. Just to be clear, it's not a service, it's technology. gRPC. First of all, I'm Alex from Boxel, so I work at Vente Exclusive. It's like a flash sales shop located here in Belgium. We started doing Benelux and also Scandinavia. We are part of the Vente group. It's a bigger group that influence. I'm also a Google Cloud expert. gRPC, so the agenda. So I'll do an introduction of what it actually is. We'll do a live code demo, so it's okay. And then we'll do a deeper dive into some of the things that make gRPC unique. So probably all of you are using kind of resting. So who remembers the day when everything was RPC? Cool. So who remembers Corba? Yeah. So I've actually looked up how many pages the Corba spec was. So the part 1 is already 500 and more pages. Then you have like 230 for the second book, and then 380 pages for the complete component model. So it's like a lot of things. It has also a bad name in the Java space because what the hell is this Corba package doing? I'm not using it at all. So it's quite hard to refactor the GVM that we have just because all the Corba things are in there. So I'm quite happy that I never had to use it. Decom, so the Microsoft equivalent. I had a book like this, so I had to use it. So it was also a very scary remote procedure technology. So if you think COM is scary, Decom is even worse. If you live in the Java space RMI, it's quite usable though, but interoperability. It only works within the Java space. You have the same things within .NET and so on. So it's all stacked together just in technology. So it works, quite handy to use, but only within the same stack. So yeah, and then SOAP. SOAP is actually something that works, but yeah, it's XML, so it's slow. And then with all the WS Dead Star technologies stacked on top of that, it also got a bad name. But it's at least interoperable. But the world has moved on in kind of more of a REST way. If you see all the APIs coming out, so all the ones from Google, they're all REST-based, at least at the top layer. And it works. But you have to think of all calls like in document kind of fashions. So if we have like now a kind of stable working technology, why is RPC back on the table? Well, it's because of this. So you see more and more companies moving to a microservice kind of way. Certainly now with Docker on the table, Kubernetes on the table, you can easily make a lot of small building blocks. You need to let them talk to each other. And okay, you can build REST interfaces, and that works, but sometimes you have like more coupled things that you do not want to spend time thinking about model. How do we translate the call for getting a transaction, or for example, for a payment? How do we translate that in a document kind of model way? So it is maybe easier to say, let's reserve this this amount of this credit card just to a call. And then instead of how do I have to do a post on this, and see what we get when we do get. Oh no, we have to upload it, update it, and we now have to do a but just to use the verbs for that in HTTP. So it's then maybe easier to just use RPC kind of in use. So Google, they came out, well, not only Google, but along with Square, came out with gRPC. So it's not Google remote procedure call, but it's gRPC remote procedure call. So they came with that because, yeah, internally they already used everything. All their microservice, you know, that Google has been using like microservice for decades, well, more than a decade, decades. So everything is coupled together with RPCs, tightly coupled. But it's with technology called Stubby, and it's very tightly coupled with their system. So you know, if you build like a technology in-house, you don't, in the beginning, don't think about open sourcing them. Yeah, there is a lot of things that are tied to your business. So they started to think about those things and see how can we bring those things together, because we are now in the cloud business, so maybe we can bring out those RPC kind of calls within our technology stack as well. So about Stubby, so 4 generations of it, so actually gRPC is kind of the 4 generations. And just to have like a number, at Google they do like 10, it's in the 10, so it's like 10 billion RPC calls a second. So you see there are a lot of things there. So gRPC, what does it entail? So what was the mindset behind that? So is to create a simple technology, simple to use, because if you have like something like Corba, or that with like 5,000 pages you have to read before using it, that's technology that never will take off. So it needs to be simple, it needs to be performant and scalable, because if you're doing 10 to the 10th number of RPC calls per second, it needs to perform. And also interoperable and extendable. Interoperable just to make sure that if you make an RPC call from Python and you have like a server in Java, that they work seamlessly together. And extensible, just if you're working in kind of business, there are also always some stuff you want to extend in your mechanism, like tracing information with your RPC. So RPC, what does it use on a technology or a lower level? So it's protobuffer tree. So it's the we will go into detail that a bit later on. So and IDLs and HTTP2. So protobuffers. So protobuffers is like a binary representation of your data. So it's like more like a message system, a message representation of your data. So it uses an IDL, just like all the other kind of RPC calls. You describe what your message looks like, what your service like in a DSL. And it's called an interface definition language. And it's a binary format. So again, it's not something serialized into text, into binaries. If you have like lots of procedure calls, you can have like a lot of more throughput with binary messages. So some benchmarks, like in general, next to JSON HTTP REST calls, you have like 3 times more throughput just with the binary format alone. So not talking about gRPC or HTTP2, just with compressing your data into a binary format, because you do not have to repeat all your fields. The fields are just numbers. And it certainly makes sense in the cloud. So you pay per machine or per amount of CPU time you're using. The less CPU cycles you use serializing and deserializing your message, it's money you don't have to spend on those cycles. And also there are some well-known types baked into that. So you have the standard formats like strings, all kind of integers, floats, and so on. And also a bunch of higher level ones like a timestamp. So timestamp is very good to have like standard defined, because if you have like non-defined timestamps in your format, and how you're going to represent it as a string, as a number since 1970, and so on, it's well defined in the well-known types what it is. What does it bring to the table? So it brings then code generation. So you write your definition in your EDL, you put it to the proto compiler, and it generates stubs for you, like in around 10 languages. So stubs for the server and for the client. So we have like those defined, so Java, C++, Node, Ruby, Python, Objective-C, Go, and PHP. Those are out-of-the-box supported. So maybe not all the super sexy new languages like Rust or whatever. They're not supported yet, but I think with this set of 10 languages, you will have like the majority of the businesses. There is indeed no C#, but it is indeed supported. Because we're a company that doesn't use a lot of Microsoft technology, and that's why we're looking at it, because it also has C# supported out of the box. It's one of the main line. And people looking at .NET Core, the 1.1 version of gRPC is coming out with .NET Core support as well. So good catch. How do you define like a message? So define it like this. So we're talking about Proto 3 because gRPC uses the third version, or actually the second version of Proto. And you define your messages like this. So if you have like gRPC, you're not going to talk about objects, but are going to talk about messages, just to make sure that you're not going to reference something. And sometimes in RPC, you think about giving a reference to an object or not. That's not the case. It's always, you always pass it as a message as a whole. So you define it here. This is taken directly from a tutorial. So it's a search request. You want to do a search. You define your fields. Nice thing about those fields is there is a style guide. So they say make your messages like this. So result underscore per underscore page. And if you generate your code for your specific language, like C# or Java, the compiler will make it into the style of the language itself. So if you have like the Python generated, it will actually look like this. But if you will generate the objects for Java, it will make set result page per page. So if you keep the style guide as defined in the language, the generated code will get the style of the language. Then the service. Proto itself does not generate the code because gRPC is built on top of it, but the specification of how to define a service is baked into the EDL. So the service you'll describe as this. We're going to make our search service. This is the method, it's the RPC call. We'll take this in, and we'll take this out. very simple, not a lot of tra-la-la. And also options. Those options give hints to the compiler that will generate the code. So Proto itself doesn't know what it is, but the compiler will pick up those options, like the Java package where we will generate our code will have to look like this. The Java output class name will have to look like this. Do we do a C#? We will have it in this kind of stuff. Package. You also see that the style is here also different as well. And each compiler that targets another language can define their own options. They are then described in their own subset of language targets. The second part of gRPC, so we have our description of our languages and our code generation, is it's built on top of HTTP2. HTTP2 as well is a binary format. You see, the protobuffers are binary, then combine it with HTTP2, it's also a binary format, is a complete, your full package is completely binary, making it extra performant. Also, it has multiplexing. It's very interesting because you know the typical use case where you have like a lot of calls to the same server. Typically you do a call, it makes a connection, get your response, the connection is broken up, do your next call, and again and then again and again. So in HTTP2 you only have one connection that you make to the server and everything is multiplexed to that. So you can fire multiple requests and your responses can, over that line, can come in another order. So the first call is really faster than your bird or whatever. It will come on over that line and it will multiplex. It's also secure by default, so it has SSL baked in. You can bypass it, but the default is that it's over HTTP. And you know, if you would not have this multiplexing combined with TLS or SSL, you know what happens with SSL. You create a key, you have all those negotiations to have your protocol, then every time your connection you have a key that you're throwing away. So you have like a big HTTP TLS key belt you're wasting. It also has streaming support. Typically, HTTP is response and a request, and that's it. There are a lot of tricks and so on to get streaming or long-lived connections that you can do over HTTP 1, but HTTP 2 has streaming baked in from the beginning. So you have like server-side streaming. Typically, you do one request. You say, I want to have the results from this point, and then the server will be constantly giving you updates over that line. So you can just keep your connection open, just listen streaming-wise till the data comes in. You also have client-side streaming. It doesn't matter or bidirectional. It could be that you're saying, I want to update the server constantly over this line, and just push things through just to the server. gRPC also defines like a standard error set that is also supported over a lot of different languages. It's getting dry quickly. Thank you. So it's a lot more than defined here. So it's like 20 or something, but they're defined. It's you can compare it a bit like the HTTP 200 and so on. They are well defined within gRPC. And they're also using standard error messages, and they're also transferred over the standard HTTP constraints. So but just to make sure, this HTTP is not to confuse with the REST. It's not because gRPC is completely over HTTP that we are talking about REST concept, because we are not using the verbs like get, post, delete. Internally, if you look deeply into the spec, it will be all like post, but you're not constrained by juggling around with the path and query parameters for doing some special kind of things. It's just like adding a procedure code. So, a code session. We're going to make a Gravity RPC. So Gravity was one of the things that I find fun in the university on the computers. It's playing a game where you have like 2 bases and just have to fly missiles from one base to the other and hope that you get it. We're not going to do it graphically, but conceptually going to try to make that. So, but we're going to start with an hello world. Okay. Let's see. Mirror. Alright, so we'll start with our proto file. So you'll have to say proto 3, otherwise by default it will take the version 2 of the language. I actually do an import of a timestamp, but for the hello world I'm not going to do that. So that's what I talked about, the well-defined types. Those timestamps are again proto files that are built on the very low kind of primitives. We're going to use that here. I'm going to do it in Java. So I know who's kind of the Java kind of only one node there. The rest is Node or?
No, we're just shy.
What?
We're just shy.
Or you're just shy. Or the Python, anyone? No. Go? Okay, we'll stay Java because I'm prepared in Java, not Java. So the class name where everything will be encapsulated, and this is the target package. So the hello world, what do we want to do? It's to like give a message, and just echo it back, and manipulate it. So define our message. Hello requests. So we're going to give it, of course, a message. So that's one of the primitives, like like 64, kind of a primitive. You can have like arrays or strings, for example. It's very repeatable. String. Repeatable, is it repeatable? It's not repeatable. Skip that. The maps are also types there. And this, of course. So this is our input. We're only going to use the message. But it was just to let you see what kind of inputs are there. And we have our hello response. And we're just going to return an echoed message. Okay, so that's our in and output data. Service. Hello world. Alright. RPC call. We're gonna call it echo. So the style guide is this kind of style for services and calls. And as fields, it's like this style. So with an underscore and lower caps. Requests. Returns. Hello. Response. Very simple. And that's our first service. Alright, now what do we have to do? Like in each kind of platform, in this case Java, the tools are kind of baked into the standard kind of tooling. Like for Java, it's Maven and Gradle. And each platform has their own kind of set. And if it's not built in, they're provided as a proto compiler extension. So for like .NET, where there's not yet something combined in the standard tooling, oh no, sorry, .NET is, so they're using NuGet, but in Python, for example, you just use the proto compiler and generate your code. In this case, we have just Maven integration, and we'll make. Let's clean it up first. At the client, we're going on the server. So, target is empty. Let's compile. Voila. Then we have our generated code here. And the syntax. Oh, of course, that's stupid. So it didn't work. Why not? I forgot something very critical. Is the giving your names and messages identifiers, and those identifiers they will translate into the binary format. So we'll have to give them a number. It doesn't need to be like this, if you can mix them around, but once you've given your number to your field, it needs to be fixed, because it makes it extendable as well. So, so later on you can deprecate some fields by removing this and say this is the number 1 is reserved, this name is reserved as well. This kind of looks like strange, but it adds to your versioning mechanism. The thing is, identifiers from 1 till 15 take the least amount of bytes in your binary format. So if you have like a field that is coming along always in your message, make sure that they're in the range of 1 till 15. Otherwise, your identifier will take 2 bytes. Hold on. I'll use something else. Nope. Okay. Again. Okay, now I have my server. Again. Well, this is generated code. It's a lot of code, but you actually don't care about it. You just keep it in a generator. Now we're just going to use it. So we're going to build our server. Our service is empty. Bigger. Extends hello. C dot extends override our echo. Voila. Now the first thing you will notice is that if you're used to Java or a lot of other languages, is that you do not have a response. You have a response observer. It's because the thing is that on the server, you'll have to build things asynchronously. So, because our gRPC can work async or sync, but on the server, you have to write it async. It's up to the client to decide how he's going to call your service. Is it async or not, or sync? Sync, if you call it sync and it's async in the background, that will work. But if you like write your server synchronous you and want to try stuff async, that doesn't work. So you will have to give your response the response observer. Now this is an unarray call, so we only give one thing back. So what are we going to do? Is we'll get our message, request, message, request, alright. Manipulate it. I'm going to echo it around. Right, it's enough. Okay. I'm going to build a response. We're going to use builder pattern, set a message, build. Alright. Use response. And now in the response observer, we see next our response. Okay, that's correct. And we'll have to say that we're complete. Now, it's a bit strange because it's an unarray call and we only give one thing back. But the interface is just the same for streaming implementation. So if you want to concentrate things, give back, you just call on next, on next, on next, on next. And if you're ready, uncompleted. That doesn't mean uncompleted that it waits or buffers everything till it's incomplete. As soon as you call on next, it will try to send it out. So that's how that streaming works. Otherwise, it wouldn't be streaming at all. Okay, so that's quite easy. It's generated code. Of course, we don't have a server. We'll create a server builder for port 4042. We're going to add our service. It's the Hello World service. Hello World service. Well, that's it. And build. Server. Alright. Open started. And await. So this is our main. So all this does is start a server, starts listening up on port 4040 on local hosts, starts and awaits, otherwise it won't terminate directly and your server is terminated. So we have our server implementation. Now it's time to make our client. So I just made Hello World, up. Now I'm going to just copy around the proto file. If you're like in a big business, you just want to have like a repository of all the proto files in one central repository or central repository per division or something like that. So I'm just going to copy here. Copy. Voila. Again, generate code, Maven. Everything up. File. So, targets back. Generated code, RPC. Yes, we have your hello world. Okay. So the client. Let's first of all start our server. So otherwise we will forget something. Okay. Server starting. No, I put fancy hello. Understand. Yeah. Let's get back to the client. So in the client, in general, you're working with service. You have to kind of have a channel. Channel is the way to communicate with your service. So it's like manages everything, every communication. So it's a managed channel builder for address. It's localhost, and it was 4042, right? Like I said, it's secure by default, so we're going to do no SSL thing here, because due to time constraints, you just use plain text. It's not SSL at all. So we have our channel. Of course, channel, that's nothing. You still need like your stub to communicate with your service. So I'm going to do that. Hello world. RPC dot. How did I call it? New stub. So we're going to create a new stub. Here you have the choice of using blocking stub or stub. We're going to use that for simplicity. But if you want to do asynchronous stuff, you can use the server or just a standard stub to work asynchronously. But we're going to do the blocking one. Up. And we're giving a channel. And block. So, do it by default. There's a stub. Wow. And now on the stub. Echo, of course, we need our request. Build it online. So the hello request dot new builder set message. DevFest build. Response. System out print line hello response get message. Okay, who thinks this will work? Okay, I'll wrap it up. So let's just run it. That's it. Yay, it works. So, have to go on quickly, so I'll not do the streaming example, but the streaming example is just more on next, so it's quite straightforward. Quickly, I want to just show a few of the things that makes also gRPC unique. Is the extensibility. So you just can layer things on the client and on the server, like for example header inspection. If you, for example, get a trace ID and you want to trace it all the way back to a service that you use on top, you can just extend those things, add headers, and it will get over the wire. Authentication is also built in out of the box, of course, Google Authentication, SSL, and some others. You also bind together everything with you could bind everything together with a context, and that's important if you have like a service that calls a service, that service calls another service as well. And you can build that in one big context. And that's important for deadlines. If you start here and you have like a deadline of 2 minutes, and you have a call here, and up, the deadline will just get propagated till here, till the time it started till here. If the deadline is reached and we don't have a response, everything gets cancelled. That's in the same context, and that's very important in microservices. The same goes for cancellations. So if you, like a scenario where you search something and you want to delegate it to different other services, and you get your response, and the first thing you get back is the important one for you, you just can cancel the other ones, or the other kind of responses that you have. I'm not going to get into version strategies because it's with the numbers, and like the classic one is with versioning as well. So in general, in the rest you do it sometimes in the path, but you can do it with namespaces, like in the packages. So gRPC, it's a first-class microservice protocol. It's kind of a protocol. It's simple to use, so not a lot of things to remember. You can build your RPC calls. It's performance scalable due to binary and use of HTTP. It's interoperable between at least those 10 implementations. So, questions?
How does it compare to Apache Thrift?
The Thrift is Thrift and protocol. It's on the same level as the protobuffer.
Yeah.
So it's not on the gRPC side, but you can do gRPC with Thrift, but it's harder because the protobuffers comes out of the box. So you have to do your serialization with Thrift as well. But it's, I haven't tried that, but it's made for that to be extensible. You could even do JSON over gRPC as well.
And how do you discover these services? Because you have no idea where they're running, and this is one of the problems we've had in the past. So we could just use Kafka and put it in queue and let some of the services.
But yeah, Kafka is like more like PubSub oriented. This is remote procedure call oriented. So you cannot compare them.
It is PubSub at the same time because it's asynchronous and you have no idea.
Yeah, but it still is a bit of a mindset. Huh? While you have like Kafka, you put it on the bus and you do not care anymore what's come there. It's not that you are waiting for a response in general. So the mindset is a bit different. And talking about discoverability, it's made for in like microservices where you like discover your things from outside or configure those things from outside. You can extend it with name resolver as well. If you have like special strategies with extensibility, you give a new name resolver and it will do that. I was thinking about when I worked this out because we're working on Kubernetes. Is maybe I can ask Kubernetes with this kind of labels of what are the services with that label that I do instead of using the service. I don't know if that's a good strategy on it, but it was just thinking exercise. but you can do that as well. So that's how the discoverability works.
Thank you very much. We don't have time for any more questions.
Okay.
We're running a bit.